move to module 3. There we are going to introduce into our in orchestration into our mlops system using Apache Airflow. Up to this point, we have done three things: set up Kubernetes as our execution environment, use MLflow to track experiment and manage model. We deployed a trained model as a live service, but there is still a major gap. Right now, training happens when you decide to run a script. That does not scale in production. Humans do not trigger training job manually, system do. This is where workflow orchestration come in. In production MLOps, you need four guarantees. First, scheduling. You want to retrain a model every Sunday night or whenever new data arrives. Second, Sunday is just a day. So you can pick any day. Second, retries. If a node is busy or pod fails, the system should retry automatically. Third is dependency. Training should never start before data preparation finish. And fourth is the visibility. You need a clear visual view of what is running, what failed, and why. Apache Airflow is the industry standard tool that provides exactly this. Now let's talk about what we are building in this module. We are going to install Airflow on Kubernetes just like we did the with the MLflow. We are going to use Kubernetes pod operator, which is recommended best practices for machine learning workflow, and we are triggering a training job that runs inside our fresh Kubernetes pods and logs everything back to MLflow. And before that, you need to learn the basic concept of DAG. So a DAG is a directed acyclic graph. This is just a Python file that defines your workflow. So in our case, let's right away create a file .py. So hope it's created. Yeah. Uh, Inside this, we are going to define task, and this task does not run Python air code inside Airflow itself. This is very important design decision. Instead, it tells Kubernetes spin up a brand new pod using uh, MLOps image that we have created and run a training uh, script inside that container. This is exactly how modern MLOps pipeline should be built. Airflow should become the orchestrator, not the execution environment. Kubernetes should handle the execution. Containers should handle the dependency. So let's build our uh, Airflow. So for that, let's do one thing. Let's first build our ML that tag. So I'm actually thinking what should we do first. All right, let's build Airflow first. Import Airflow. Let me add UV just for the sake, so that you don't see the errors in IDE. It's not required although. Let's give this some time. Oh, should be done. Perfect. From Airflow did I Airflow import DAC from Airflow dot providers dot cn cn I believe it is cncf dot kubernetes dot perator operators dot pod. I believe it won't work if we are actually going to run tst. All right, let's actually so I think it's not going to work. First, uh, I don't want to create some confusion, but let's go in the order. Let's build our dockerfile.mlops, a script that will start building Docker images. This image will contain everything required for training: Python, scikit-learn, MLflow, training code itself. Once the image is built, we will load into kind, and the kind so the kind actually do not seize local Docker images. It forgoes this step. So Kubernetes will keep using our old image, and your so so the idea is to what I wanted to do first. Let's create the namespace of Airflow, because namespace is going to give us the isolation. MLflow will live in its own namespace. Airflow will live in its own namespace. This will keep the system clean in production. And the very important part is the RBAC, or role-based access control. This is why I stopped writing the code right now, because Airflow needs permission to create and manage pod. By default, it does not have that permission. So we create a role that allows action like create, delete, get, watch on pods and pod logs. Then we bind the role to Airflow service account using role binding. Without this step, Kubernetes pod operator will fail silently or with cryptic permission error. So, uh, so, uh, so here, like we need to create a config map, uh, which will ensure that these things are happening correctly. And so so that uh, it's a bit complicated. So let me do one thing. Let's actually create Airflow hyphen values dot yml, and let's try to first fill that up. So let's bring the executor, return and test it. So this is a, I would say, bit tricky part here, and this configuration I have actually taken from internet itself. And what I'll tell you, the changes that I have made is this is the file name where your actual DAG lives. This is important. And in the DAG volume, you also need to mount the path. This is the only thing that I have changed. The path. This is important because what we are running here should be run in the Kubernetes clustered. So, and this is very standard thing. If you want to get more deep into this, you can go, but I'll rather for ML, we can make another video for details into that. So for example, for now, let's make things bit simple, and let's create a entry point file, which is going to be the, let's call it run pipeline, pipeline dot sh, and let's open it. This file will only, let's add bin bash, and run pipe. So later on we are also going to modify this file. This file will check if we have data change. So but for now it's very simple. It's going to call this function that we have created, train mlflow.py. That's the simple file, and then we can make one more file, touch docker file dot mlops, and there we are going to write how to run this mlops pipeline. So from Python 3.9 hyphens lim is going to be the base image, work dir, let's app, copy requirement dot txt, run pip install minus no cache dir minus r requirement dot txt, and then we can copy the training script, flow.py, and we can also copy py, because this orchestrator should have everything like how to make the APIs and all stuff. Run pipeline.sh, and let's also copy the data itself, data slash diabetes.csv into the folder data. This is important because we have written code like this. And let's also make this executable, the run file chmod pipeline.sh, and then we can just run this command pipeline sh. Perfect. So what we have just done is making sure that we have our required codes available to us before we are going to load the inside the kind. We can first pass our diabetes model. So let's do one thing. Let's build it. So docker build minus target diabetes model server latest dot. So this docker file, it's going to build. Perfect. And then we can load the same step that we have done. Docker images type and diabetes model server latest, name as mlops cluster 1. Let's server, believe must have made some typo. Let's try again. Oops. All right. So it is already loading. So I just wanted to make sure that we have done this much. This much should be done to run what we are going to do the next. And so we are actually going to build this file diabetes mlops latest with docker copy. Oh, so this is, yep. I believe I have, yeah. So, and we can load into our cluster, same thing. We can load, and then we can we need to create the airflow namespace and RBAC role based access. So for that you can type kubectl name space airflow. Let's make try run. It's actually going to take some time. -o YAML, and then kubectl apply -file, and the and then there is a command Although I tried to make this work. All right, so it's going to be a bit clumsy. Let me try to run this in the set airflow airflow. Let's run this. What should I make? Uh, setup dot search, and let me try to bring the command one by one over here. So this much worked. Now what we need is the kubectl. I'm actually going to explain you. So the thing that I explained is pretty much these things where you need to have the get list watch create permission, and this is what we are doing here. And then rbac, the namespace should have these I mean, or web server should have these operations. These these things are again pretty much standard. I have not made anything changed. If your namespace is different, then you can just change the namespace here. But uh, you should understand, like, the RBAC, why it is important, because Airflow needs permission to create and manage pod. Without this step, the thing that we'll try to write in our Python code won't work. And then once this is done, let's go and using kubectl, we'll create uh, this client, and we can install using Helm. We can uh, bring the Airflow chart, and then you can also doing that after is important to update. So we use value file that we just have created for the Airflow. In there, it's important to, because it's important to have a correctly mounted for mounting of our DAGs, and that we have defined in the Airflow hyphen values. So this is important. And Airflow setup, and then we can wait for the server to load. Same thing that we did, if you remember, for mlflow. Wait for until this is done. This is going to take actually 5 minutes, and we can create any existing one because I actually have one running, and then we can port forward 8080 to 8080, and we can then echo if everything works. Then EC echo Airflow UI at tippy slash closed 8080, and you can pass the password admin. And then now we can start building our, let me actually bring, because this session is getting bigger. So yeah, you need to bring from CNFCF operator pod, Kubernetes pod operator, the arguments, who's the owner. It does not depends on any past. Start date, you can mention email on failure. This is standard configuration. This is the default arguments. And then this is how you define your deck. This is diabetes training Kubernetes train, diabetes model, description, and manual trigger. Do you want schedule interval? If you want, you can provide a cron expression over here. So now this is the pod operator. You need to define your namespace, the image that we have built, and then it runs train.py and label this as diabetes training, and image pull policy will use kind cache. And then you all in environment, since we are setting up the ML flow tracking URI, so this is something we can pass as the environment in that Kubernetes pod. Very important. So I think now we are pretty much ready on. Let me see if everything is correctly done. So once this is done, let's make it executable. /airflow setup.sh, and let's run. All right, it was a difficult one. Okay, I believe we have made a change. Sound. So the cluster name is this. Let's cancel this. Again, small mistake. For you, I mean, you can prefer to omit one, because since I have run this one, actually I'll also teach you how you can delete it. So I mean, in future rather you can just change. Let me quickly see my all. Yeah, we won't see any error. It's going to take some time, and let this take some time. About, it's going to actually take 5 minutes. Let me pause that, and from then I will begin again. Okay, so Airflow is installed, and let's try to open it. Okay, I can see my DAG over here. Let's enable it. For now, you'll only see one node. You can chain it with multiple steps, but this pretty much has everything. It's going to train our model. So let's run it. See if it is working. Let's click on log, and it is running. Perfect. Our model has trained. Let's check MLflow and verify if we have another version. That's exactly we wanted. we have just achieved Airflow. This so if you understand, if you are paying attention, what just has happened, the model is not trained through running something here in this Python terminal. No, actually we have spun up a pod there. The pod was created, deleted, trained. Airflow is doing everything. So what it is doing, it is asking Kubernetes to create brand new pod using diabetes mlops image. This pod will run training script. Script will talk to mlflow, matrices, parameters. Model will be logged exactly like before, but this time no human ran a Python command. If you click on the task instance and open log, you, you so you can see it's here. Version 2 is here, and one key insights here is the isolation. Airflow itself does not need scikit-learn. It does not need mlflow installed locally. It only needs permission to ask Kubernetes to run the container. This completely eliminates dependency conflict, and it works on any machine. One important reminder, if you change training code, you must rebuild the Docker image. So for that you can run kind load Docker image. Otherwise, Kubernetes will keep using the old images. At the end of this module, you now own a fully orchestrated MLOps pipeline. Training run inside the Kubernetes, execution is triggered by Airflow, experiment and models are tracked by MLflow, and everything is in front of you. Everything is running locally. This is the same architectural pattern used in matured machine learning platform in production. I just shown you a glimpse of it, and a production graded control that turns into true end-to-end MLOps platform. So this is where most, I will believe, most of the machine learning educator might have reached. To show you, we are going to take this to the next level and introduce something called monitoring. So in the next module, we are going to learn how we can integrate Prometheus and Grafana in our MLflow project. Thank you.